Hey everyone, welcome back to the channel, and today we are going to be talking about Teapot. So what is Teapot? Teapot is a collection of a bunch of different honeypots. And you might be asking, what's a honeypot? Well, a honeypot is designed to act as a way to attract attackers and get them to log into something, maybe upload a file. Basically, it's trying to emulate a system being compromised. And the purpose of that is to try and understand what's going on in the wild, what's going on with the, all the APTs out there, and trying to see if there's like a whole new trend going on, see what's happening. And a lot of things you can do with this is you can look at all the different services that are being hit. And say you're monitoring Cisco ASAs because you have a lot of Cisco ASAs, and it's your job to protect all those products. Well, if you set up like a honeypot network or you use someone else's and you start seeing an uptick with ASA Cisco's specifically being attacked, then you might start realizing, okay, maybe there's a new CVE, maybe there's a 0-day. There's something happening that is triggering this uptick in activity specifically aimed at Cisco ASAs. So you could spin up, some Cisco ASAs and hope to get some of that activity and get them to log in, get them to launch attacks against you, and start evaluating that information and kind of see what's going on. Is this something new? Do we need to be worried about it? And what you can also do is if in some cases, like say SSH, for example, it's really common for them to download payloads. And just to demonstrate that, this was a file that I pulled down and, did some research on it. And it's specifically looking to do coin mining. And there's like a lot of information you can start pulling up from a lot of these information. So if we look at, the little instance that we have up and running, we'll talk about how to deploy this so you can use it yourself. But let's go down to Cowrie and take a look at what's happening. And this has been running for about 2-3 days now. But looking in the past, 24 hours specifically to SSH hits, we're looking at about 1,500 unique IPs, almost 90,000 attacks. Attack volume is pretty stable. And we can see there's a big increase coming from one country now. And most of the hits look to be going to SSH, a little bit of Telnet. We can look at the passwords being used, the usernames being used. Going down here, as we can see, we've got the file name, the download path where it's currently residing. You can also just pull it directly from the URL, which is what I did. And we can start evaluating, seeing what's going on. Quickly looking at the command line input, we can see that they're very, very curious about the kernel running, the system information, CPU info, which kind of lines up when I looked at all the exploits that were being downloaded. Is they're all based around crypto mining. So I'm pretty sure they're specifically trying to find some ideal CPUs to be able to run all their crypto miners. This is by default top 10. I went in, I modified it so I could see what else was being run as well. And you can see it's a lot of the same standard content, some fancy things. Looks like they're trying to modify some SSH, but it's kind of interesting too, looking at the command lines that are being ran. And what you can also do with the command line input is if we start seeing something very commonly used by the attackers, we can take that command line information and we can start doing threat hunting in our environment. We can take what we see, start looking for stuff specifically. Maybe you're not doing monitoring on command lines, or maybe if you are doing command line monitoring on Linux specifically, you're not looking for hex values. So this gives you an idea as to what's happening, and you can expand your threat hunting. And looking at this is like, okay, maybe we need to start looking for BusyBox specifically and seeing if there's anything happening with that. So this is just a quick way to kind of like give you an idea as like what you can do with this. And this is much, much more in depth. There's like so many more options. We can use Suricata as well. So this is just running all the Suricata alert information against the incoming traffic. And this one's a big one. I think I saw about 10 million hits at one point when I was browsing through this. As you can see, it's definitely taking some time. Pretty heavy. There is also this one spike, about 1.4 million hits in a pretty short period of time. That was kind of interesting. So it's spikes like this that we find interesting, and we can look into this and see like what was happening and why we were getting that type of a hit. Most of them seem to be like this specific SID. You can also go in and monitor this, or you can just query specifically and look at all the different ones that are happening. The top 10 is kind of nice, but I like to go deeper than that. So we have the CSVs, CVs being used as well. Top source IPs, some of the networks. So that's kind of interesting. But yeah, there's a lot you can do with this, and there's 2 pages. Deployment, I will say, is definitely intensive. They recommend 8 to 16 gigs, and that's pretty true. For me, I'm running a couple of sensors in a Hive. The Hive is like the main Kibana instance where you can like do your browsing and look at all the data. I tried running this, the standalone edition, on 8 gigs of RAM. It didn't do so well, it kind of crashed. But running just the Hive without the sensor data on it seems to be pretty stable at 8. The sensors I tried running on 2 gigs of RAM, but they would spin up and they would run. The only problem was I could not get the sensors to connect to the Hive, which ruins the purpose of having the sensors up, since you want to send all that data to the Hive for reviewing. So that's just some information I found. You could probably go in here, you could maybe make some modifications, reduce the Docker containers, find a way to reduce the load. And most of it seems to be running around Logstash, so maybe you can tune that. It is Java based, so keep that in mind, but you might be able to squeeze that down. And the reason I say that is because it is cost effective to reduce your memory usage and CPU usage requirements. This is me running a couple of days now. Isn't too expensive, but as you expand and you want to grow out, maybe you want to deploy 10, 20 machines, it can get kind of costly. But just to give you an idea, this is what I'm running on Vultr. You can use any web host that you want, as long as you can do a custom ISO. That's how I deployed it, and we'll walk through how to do that as well. Looking at the back end, pretty common. They just run a bunch of Docker containers that are open source honeypots, and you can kind of get an idea which ports are forwarding to which honeypots for that information. So we have a 22 SSH, which is going to this Docker container, and you can kind of get an idea which ports are open and which ones are running. So if you want to quickly have a reference sheet on which honeypot is doing which information, this is very helpful. And then we also just have like the packet analyzers, which is Suricata over here. And then we have the standard elk stack setup, and then their little communication here as well. Finally, it does have some other information. This lets you manage your Linux machine from the web browser, which is kind of cool. CyberShelf, if you've not used this, it lets you do a lot of different modifications, which is kind of cool. Spiderfoot is actually really cool too if you want to do some investigations, and then it also has an attack map. And the attack map is pretty standard. It's going to show which machines you have, their location, and what attacks are coming through. I will say that some machines will get attacked a lot more than others, and that's definitely a pretty big hit. Someone just launched something, but placement of your machines does matter. I will say some cities, some countries will get a lot more hits than others. So that's just something to keep in mind if you really want to get a wide range net and see what's really going on. That's definitely something to consider. But if you really want to see which machines are being hit the most, we can do that with a custom lookup. So I'm just going to go here and just go to Discover and find the host name table. So this has a lot of capabilities. I'm not the greatest when it comes to using Elastic Kibana type style. I'm more of a Splunk Sentinel user, but if you've done KQL style queries, it's pretty common. I'm just going to come down here and I'm going to find the host name, teapot host name. So I'm going to look at this and visualize it, and as you can see, each one has a different name. I don't know which machine is which name. I didn't take note of that, but it does automatically generate these names. And as you can see, some are getting hit a lot more than others. So this is just kind of like nice to see. I'm assuming this is probably my main machine here that's hosting Kibana, and these are going to be my sensors. but it's a nice way to be able to visualize, and you can click on visualization, and you can always customize and build this out and kind of like see, which ones are being hit the most, and you can kind of like, use that if you want to spread out and migrate your your monitoring. Okay, so now let's talk about deployment. Deployment's pretty simple. You just need to upload your ISO. So I'm going to go ahead and do a deploy new server. And I'm just going to do cloud compute. I do basic. You really don't need anything too expensive. So I just kind of go with the cheapest I possibly can get. And I'm going to go ahead and spin up a standalone, since most will probably want to do a standalone edition instead of trying to build out the entire Hive honeypot layout. Okay, so I'm going to grab this. And I do recommend doing a 16 gigs of RAM on setup if you're going to be doing a standalone. Don't really need automatic backups. I understand the risks, and I'm going to do a deploy now. Alright, so this is going to deploy, and it's just going to take some time. Once it comes up, we can go ahead and go to the console, and we can start looking at the installation screen. If you set up Linux, it's a lot the same concept. You're just going to like walk through the steps and say yes and no to things. Nothing too complicated. So we go here, we're going to do view console. Just going to pretty much say yes through every little option. Installation will probably take about 10 minutes. Once you go through the installation phase, it's pretty simple to move on. Okay, so it's finalizing the installation. Some other things to keep in mind when working with honeypots is you can also take the information and send to other SIEMs if you would like to. So let's go into the cloud instance here, and I want to go to settings, and I want to remove this ISO. And once the ISO is removed, we can go back to the console, reconnect to it, and now it's going to just boot into the OS, and we can go through the final phase of installation. So this is where you're going to set up your username, password, some basic information like that, and then instance will come back up. You can also define which type of instance you're going to do. In this case, I'm doing a standalone, which most of you may actually want to do. If you just want to play around with the information, kind of like see what it looks like, and just have some fun with it, standalone would be the most recommended option. In terms of how long it takes to get the data in, you may need to take a couple of hours and just let the attacks come through. You will see some pretty quick, but some of the other honeypots will not get information as quickly as others, so just keep that in mind. I typically would just install it, let it sit for a day, and then come back and play around with it. So these are the different additions we can use. I've been deploying Hive. I have a Hive that we looked at, and then I just deploy Hive sensors, which have all the sensors, and they send the information to the Hive, which is the elk stack setup. You can also do an industrial. They have one for medical. They also have one as a mini. And if you just want to use just a sensor, which is just honeypots and NSM, this is a nice way to just have the most basic, and then you can take the logs and send them into your own SIEM that you choose to and play around with logs as well. So that's a good minimalistic approach if you want to play it with that way. So there's a lot of nice options that let you quickly install this application and utilize it. So I'm going to go ahead and just set myself a password and hope it's not too easy. I'm going to give myself a username and give myself a password. There's another thing to keep in mind in terms of security with one of these is live under the assumption that it's been compromised. And that's just because there is a lot of activity coming in. And despite the fact that you can develop these honeypots and make them emulate, real services, real products, it's still always best to operate on the assumption that it's been compromised, expect a compromise, something like that to happen. So make sure that you take specific security preparations if you're deploying this in-house. Keep it in a DMZ, something like that if you're going to run internally. Even if you're running externally, make sure that if it does get compromised, it's not going to take any sensitive information, or that there's going to be like an SSH tunnel or any other type of tunnel that's going to go back into your network and not be monitored or for protection. So just keep that in mind, because you do have a lot of open doors and windows on these type of machines when they're a honeypot. So just always have that in mind. And on the topic of internal deployment, if you're doing honeypots inside your network internally, you might also want to look into doing honey tokens. Honey tokens is the same type of concept, but instead of services and products, you're using files, for example, directories. And they can have callbacks, macro scripts that when opened, they send a signal back and you get a notification like that a file that was opened should never have been opened. So you could use a passwords.txt or XSL or a Word doc, things like that. And you want to make them, tempting to a hacker. They're going to look for something specifically that's going to have information that they can use. And you can also use it for a directory. Say you have an HR directory, and this is like a real life practical example. You need to monitor, make sure that only HR is accessing and user records. You can set up Windows event logging if you're using a Windows file server, and then do specific IDs. And when a certain ID fires on that directory or that file, you can have your SIEM create an alert and you get a notification. So it's the same concept, like doing something like that. You can also apply to like honey tokens, so you can see when an attacker is on your network and accessing specific directories. And the idea is you want to make sure you pick locations that are tempting, but you also want to make sure that it's not something that a normal user is going to access, because you're just going to end up getting a lot of alerts from typical activity. You're looking for a place that's not going to be touched, but also not going to be too obvious to an attacker that this is a honeypot file, this is a honeypot token type thing. So that's definitely something to always keep in mind when deploying that. But it is a very valuable solution to have in your network, because it gives you some good insight. And then when you do have a hacker touch that token, there's things you need to keep in mind as well in terms of how you want to handle that. You may not want to actually stop the attack by doing a firewall block or disabling the account until you know exactly the extent of the damage, exfiltration, the initial compromise. And that's mostly because if you don't know how they got in, they're probably going to get back in again. You also don't know if they've set time bombs, and if you lock them out, they might have the attitude of, well, if I can't get anything, then you get nothing, and I'm just going to encrypt all your data and now you have a ransomware issue. So it's a really good idea that when you do get an invader in your network, that you start doing your analysis, try and get an idea as like to what happened, where they're going, what they've accessed, making sure that the proper systems are being isolated while you try and contain the attack. So these are a lot of things you need to think about when you do have an attacker in your environment. And honeypots do provide a lot of information, so you can kind of like see where they're going in a nice visual way. So just a lot of things to keep in mind, but always keep in mind that the big important thing is once you do find the attacker, make sure you have policies and procedures in place on how to handle that situation. Because detection is always one part of it all, but the biggest is how do you deal with it. All right, so right now we're still waiting for it to finish the installation, and it's right now just pulling all the different Docker containers and doing the configurations for these Docker containers. And the other thing too to touch on why I don't specifically really like this instance or this project really is because the complexity. And because I didn't build this, I don't understand how it all works properly, where the debug logs are all being kept or how to troubleshoot. It becomes an issue if you do deploy something like this in your environment. You always got to keep this in mind, is who's going to manage it, who's going to maintain it. And if something breaks, something happens, what do you do with it? How do you fix it? So I had this issue when I tried running the standalone on 8 gigs of RAM. It ran fine. A day later it came back, nothing was working. I tried to do a reboot, nothing came back up. Didn't really know what happened. I just moved on, rebuilt it. So that's just something to keep in mind when working with something like this, is there's a lot of moving parts and you may not have the time to be able to troubleshoot, debug it if something happens. So always keep that in mind when deploying any type of like software product, is make sure you understand the costs and time required to actually manage and maintain it. Okay, so we have our teapot up. I'm going to go ahead and try and expand this window so we can see that IP address. And we have, let me grab my little notepad here. I'm going to go ahead and type the IP in. And there's multiple different ports. This is going to be the web-based one right here. which will give you access to the main web interface. SSH is on its own specific port as well, which is 9.5. And then the admin, which was the co-pilot, or cockpit I believe it was called, is on 9.4. So just keep that in mind when making access. So I'm going to go here, copy and paste it up, and hope I copied that in correctly. 88, oops. There we go, okay, cool. Go to accept, and I'm gonna log in with my very sophisticated username and password, and here we go. So now we have the standalone edition spun up. I'm gonna click on Kibana. So it's gonna look just like what I was showing you at the beginning of the video, but you're not gonna have really any data in here. So we have all the different ones. We have Q, honeypots, take a look at that. And this is what's going to come up with when you have no information yet. You're just going to see a lot of, the fields are blank. Let me just go grab one that's going to probably get a lot of data, Suricata. We might see some things in here, maybe not. Yep, there we go. We got some events coming in. It's kind of cool. So that's pretty much how simple it is to deploy Teapot. So maybe you want to do a Hive setup like what I've got. So the way that I did it with the Hive is I did let me close out some of this. Is I created the Hive, which was the same concept as what I did with the standalone. Once you spin the Hive up, you're going to want to log into the sensor. So let me just close out of this and demonstrate logging into the sensor. So spin up your Hive, get your Hive set up, and then spin up a sensor. And then once you get your sensor spun up, you're going to want to log in to SSH, and we're going to do -L, do the username, the port number, and IP address. And then we're going to log in. And then once you log in, there's some steps as to what you're going to really do. And really all you need to do is just do sudo to su, become root. And once you become root, all you have to really do is do, I believe it was deploy sh. Yeah. So you do deploy sh, and then just, we just want to do c. Oops. Just do c, and then it brings up a username, password, and then the IP that you're going to connect to, which will basically just be this the Hive IP address. And then you just let it do the installation, and then all of a sudden your sensor will be connected to the Hive, and it's going to send the information back into the Hive as well. So that's really all there is to it in terms of building up an entire honeypot network, and how advanced you want to make it is up to you. I'm deploying I'll probably have about 10 at the end of the week deployed in different locations around the world, just to kind of get an idea as to what's happening. But I just wanted to give you an example of how you can use Teapot as a quick and easy way to build out a honeypot network and just take a look at things. It's not a bad product. I do like it. It's well documented, a lot of good options. Just keep in mind that it could become expensive just because of the amount of resources needed and required to actually run it. So other than that, I do like it. It's a really decent product, and it's got a lot of options, a lot of flexibility. And I think it's definitely something great to play around with if you really want to get your feet wet with cybersecurity and threat hunting, and just understanding a lot of the threat actors and how they work, and keeping tabs on finding threats. So I think it's definitely worth trying, definitely worth playing around with. I will post a link in the description with all the content, along with a $100 credit link to use on Vultr. If I have some other providers that have free credits as well, I'll get those posted as well, just so you have a lot of flexibility and you can go deploy in a lot of different locations. But once again, thanks for watching. And if you have any questions, comments, concerns, post in the comment section. I'll respond back to you. You need help, email me. I'll definitely give you some pointers. If you want to talk cybersecurity at some point as well, reach out. Always love to learn about other people's research and what they're doing. So, be sure to follow me on all my social medias. I'll drop that as well. And let's connect. And thanks again for watching.